Hello and welcome to yet another thrilling and chilling installment of the Algebra 1 videos. This is the last section in Unit 3, I believe, and this is called Introduction to Compound Inequalities. And when we say Introduction to Compound Inequalities, that really means we have multiple inequalities. So we have more than one inequality. Inequality. Okay, so that's the idea. All right, so we've got more than one inequality, and we can talk about these inequalities using an and or an or statement. Okay, so an and statement means the intersection. Okay, intersection of two inequalities, and then an or statement means the union. Okay. So union. So the way I like to think about the intersection and or the union, well, union typically has the word marriage, where everything from both inequalities are used, okay, are considered, or let's just say are graphed. That's what we'll probably. Okay, and then when we talk about the intersection, it's where the two inequalities share common values. So two inequalities share common values. Okay, and I'll show you graphically what that means and all that kind of stuff. But so let's take a look at what that would mean graphically. You know, if I graphed an intersection, you know, using an and statement, you know, I would say something like this, that like x is greater than, you know, say 2, and x is less than, say, 7, okay? And what we would do is we'd come here and we'd graph, and, you know, we'd have the first graph if x is greater than 2. And let me graph a couple of them. Let me do a couple different lines here. I know I'm off the page a little bit, but, you know, that's the idea. So if I look at this graph here, x is greater than 2. And I'm going to come here and I'm going to put 0, 0, 0. And then I'm going to put 2, 2, and 2. And then I'm going to put 7, 7, and 7. Okay, and what I would say is that, you know, here, you know, x is greater than 2. If I were just to graph that, you know, I would put a circle here. X is larger than 2, so I would shade this to the right, okay, what we did in section 7. And if I knew that x is less than 7, then I would say this, that, you know, if I had that all values of x are less than 7, and I would shade in this direction. So if I wanted to do the compound inequality, okay, so if I do the compound inequality, this is going to be down here, the compound, then I would do something like this, where I would say, okay, if I were to say, where do both of these share common values? And one of the ways I could write that would to say that 2 is less than x is less than 7, okay, and put them together. Because I know that we share common values between 2 and 7. So if I were to combine both of these graphs and say, okay, where on both of these graphs do I have the same values, okay, for these inequalities, then I would say that my values are strictly between 2 and 7. So what I would do is I would put a circle at 2 and a circle at 7, and then I would shade in between, okay? And this is what I mean by a compound inequality, where you're just dealing with more than one inequality, all right? Now let's look at something else. Let's say that you've got something like this, where you say you have, say, x is less than 2, or x is greater than 7, okay? And what I would do is I would graph both of them. If I graphed x is less than 2, and I'm going to graph 3 of them like I did before. Okay. If x is less than 2, then, here, let me put in these numbers. 0, 0, 0, and then this is a 2, 2, and a 2, 7, 7, and then 7. Okay, what I would do if x is less than 2, then I would do this. I would take this and I would say that values for x are less than 2, shade that way. Okay, if x is greater than 7, then what I would do is I would come over here and shade this way for that graph. But if I wanted to put them both together, if I wanted the compound inequality, and it's the or, okay? And or, remember, is where, where both inequalities are graphed on the same thing. It doesn't matter where they intersect, doesn't matter anything like that. I just want to make sure that they're both on there, okay? So what I would do is I'd come over here and I would say that x is less than 2 and x is greater than 7. And I would graph that. So that's what the graphs look like. And that's what I mean when I say, like, okay, two inequalities share common values, graph the intersection. Okay, where do they have common values? But a union, okay, you just put them both on there and just leave it. Okay? So let's take a look at a real-world example here where we use compound inequalities. And so, you have this scenario where it says, in order to ride a new roller coaster at Loops and Thrills, which sounds like the most incredible amusement park, okay, a person must be between the ages, or must be 48 inches and 84 inches tall, okay? So they got a range in between 48 and 84, okay? If they're smaller than 48, they don't fit, okay? If they're larger than 48 inches, they don't fit either. So if h represents the height in inches, what inequalities could be used to appropriately model the two heights and requirements, okay? And then what compound inequality will represent the height requirement? So what we know, is that the heights h need to be greater than, let me do this, height needs to be greater than 48, okay, and the heights need to be less than 84, okay. Now as a compound inequality, I mean, you can say the word and, but we really want to say 48 is less than h is less than 84. Okay, and I like this because, I like writing it like this because, it allows me to see that, h is going to be greater than 84, but at the same time is smaller than greater than 48, but smaller than 84. So, it's nice to know that h is just between these two numbers. So if I come in here, okay, and it must be between 48, and that means that we include 48 and 84. If they are 48 inches, then we can, include them on the right, and if they are 84 inches, we can include them as well. So what I'll do is I'm going to put dots, colored in dots, at 48 and 84, and what I know is that we can shade in between. Okay, so, if your height lands somewhere on 48 and 84 and anywhere in between, then you can ride the ride. Okay. So, let's take a look at analyzing inequality graphs. So what I want to do is rewrite the inequality x is less than 5 and x is greater than negative 100 as one and compound inequality. And it's kind of the same thing that we just did earlier, but what I want to do is say, I've got negative 100 here and I've got 5 here. Now I know that x is smaller than 5, so I'm going to put that inequality here, that x is going to go there. But then I also know that x is greater than negative 100, and it's kind of hard to see. You can flip these around, and it doesn't matter, what order they go in, but I can say that x is greater than negative 100, okay? And I can just write it as 1 and compound inequality. So if I come down to negative 100 and put a circle here, and then put a circle at 5, okay, all my values for x are in between negative 100 and positive 5, okay? Now over here, okay, now if you're given a graph, we need to be able to write the inequality, okay? So what I know is that, this is the intersection, okay? So you can say a couple of different things, okay? I know that values for x, are going to be greater than or equal to 0, okay? And that's looking at this endpoint and saying, okay, well, the values for x are going to be larger than that. However, they will strictly be less than 35, okay? And that's it, okay? That's all you need to do. So being able to read this graph and write this inequality is pretty important, okay? Or you could say this, that x is greater than 0, greater than or equal to 0, and, okay, at the same time that x is less than 35. Okay, that works too. Okay, but I like this notation because you're able to see, how, that the values for x are between 0 and 35. Okay, all right, on the next one, okay, it says graph the compound inequality. So what we have is we have that x is larger than 2.5 but and equal to 2.5, but is less than or equal to 4.5. So what I can do here is I'm going to put circles at 2.5, okay, and at 4.5. I'm going to shade in between, and that's it. Okay, that's all I need to do. All right, let's do another one. Or let's take a look at this. Here's one of those things where if you have an and statement, this is an intersection. Okay, and then this is a union. All right. So what I have here is that we can see that x is greater than negative 12. Okay, here, but at the same time it's less than or equal to 6. All right. So we have a colored in dot and we shade in between. Okay, but when we have a union, the or statement, we say that x is less than negative 12. So we graph that, or x is greater than or equal to 6. So we shade this way. So when you have these different statements here, they mean two different things, and and or, but we are looking at, where do these points lie on a graph, okay? All right, so let's take a look at writing some of these union compound inequalities. And what I see here, it says write the compound inequality that is represented by the graph. So I just look at the graph, and I say, okay, all the values here are smaller than negative 3. So what I would say is that x is less than negative 3, okay? Or, because I have two of these, I know that all the values of x are greater than or equal to positive 5. So I would say that x is greater than or equal to positive 5, okay? And you could even say that 5 is less than or equal to x. You could say it that way too. It doesn't matter. Okay. So let's take a look at how one of these would look like on a graph. And what I have is I have that x is less than negative 8. So let's come over here, and because we are just strictly less than, okay, let me come over to negative 8 and draw a circle. Okay, and we would shade to the left. Okay, or x is greater than or equal to 3. So because we are greater than or equal to, I need a solid circle at 3. And then the values are larger than that, so I'm going to shade to the right. Okay, so that's it. Okay, I hope this isn't too difficult for you. I don't think it's too bad of stuff, but we just got to understand the difference between and or and be able to read graphs and read inequalities. So get to work, and we'll see you soon. And this is the last section of the Unit 3. So please get started on your notes on the unit review. And let's take the unit test as soon as we can. So you guys doing a great job. Talk to you later. See ya. Bye!